All right, let's get you caught up with your high-speed update on everything happening in the cosmos. From our own sun throwing a tantrum to a discovery that could actually rewrite cosmic history, it was a packed day in space. Let's get right into it.
So today we're going on a bit of a journey. We're going to start right here in our own backyard with our star, then we'll take a little detour to say hello to a visitor from another solar system, and we'll finish up by peering all the way back to the dawn of time.
First up, let's focus on our corner of the universe. Our sun gave us a pretty stark reminder of its raw power, and at the exact same time, our ability to keep an eye on our own planet took a huge leap forward.
So on December 27th, solar activity just shot up. A brand new sunspot region decided to announce its arrival with a bang, erupting just as it rotated into view on the sun's edge, what astronomers call the southeast limb.
And this wasn't just a little pop. The event was classified as a strong M5.1 solar flare. Now, to put that in perspective, M-class flares are a really big deal. They're the second strongest type, and they can cause some very real effects right here on Earth.
The blast peaked around 0150 Universal Time, and that powerful burst of radiation just slammed into Earth's upper atmosphere. The result? It triggered a moderate radio blackout over the Coral Sea and parts of the Pacific, which messed with high-frequency radio for a little while.
So, while our star is showing off its fiery personality, what are we doing down here? Well, it turns out our own tech for watching our planet's weather is getting a serious upgrade.
On the very same day, China successfully launched its Fengyan 4C satellite. This is a next-generation weather satellite, and it's parked in what's called a geostationary orbit. That basically means it just hangs out over one spot on Earth, giving us this incredible, continuous view of our planet's weather.
So why is this such a big deal? I mean, it's just another satellite, right? No way. This is a huge update. Imagine you're trying to track a storm that's blowing up out of nowhere. This satellite can scan the entire face of the Earth in just 5 minutes. That's 3 times faster than before. It can pick up temperature changes as tiny as 1/50th of a degree Celsius. And get this, its lightning imager snaps 500 pictures every second. That kind of speed and precision is an absolute game changer for forecasting dangerous storms like typhoons.
Okay, from events right here at home, let's zoom out and turn our gaze to a very rare visitor that's just passing through our neighborhood. We're talking about a messenger from a completely different star system.
Researchers just dropped some fascinating new findings about the interstellar comet known as 3I/Atlas. So what makes an interstellar comet so special? Think of it as a cosmic time capsule. It was born around another star, and it just happened to wander into our solar system. Studying it is like getting a free sample of the stuff that builds planets somewhere else in the galaxy.
And here's the really cool part, how we saw it. NASA's Europa Clipper spacecraft, which is on its long journey to Jupiter, just happened to get a completely unique angle on this comet. Instead of the usual side view we get from Earth, Clipper saw it from behind. It was literally looking straight down its tails toward the core.
And from that incredible vantage point, the spacecraft's instruments picked up the chemical fingerprints of oxygen and hydrogen. It confirmed the comet was outgassing, basically just spewing huge amounts of water vapor as it got cooked by the sun. This was a critical observation because it filled in a blind spot for us when the comet was too close to the sun for our telescopes here on Earth to see.
And this gets right to the heart of why this is all so exciting. Dr. Tracy Becker put it perfectly. Studying this visitor helps us tackle those really big questions, Like, is the recipe for making planets the same everywhere in the galaxy? Or are there different ways to do it out there?
So, an alien visitor makes us wonder if our little corner of the universe is unique. Well, our final story takes that idea and cranks it up to 11. We're about to question whether the universe itself has always played by the same set of rules. Yeah, this one's a bit of a mind-bender, so stick with me.
To get into this, we have to talk about quasars. The easiest way to think of them is as these giant cosmic lighthouses beaming at us from across billions of years. They're the incredibly bright centers of distant galaxies, and they're all powered by supermassive black holes that are just feasting on everything around them.
Now here is where it gets wild. For decades, scientists just assumed there was this basic rule about how these black holes feed. The stuff swirling into them, the accretion disk, glows in UV light. And there's a super hot cloud above it, the corona, that blasts out X-rays. Everybody thought the relationship between that UV light and those X-rays was a constant, a fundamental law of physics, the same everywhere and for all time. Well, new research says that's wrong. The physics have actually changed over billions of years.
So, wait a minute. A fundamental rule of how black holes work has evolved? Okay, cool. But why is that such a big deal? Why should you care?
It matters because it pulls the rug out from under a core assumption in astrophysics. It tells us that the way these monster black holes grew up in the early universe was fundamentally different from how they work today. This means our detailed models of how galaxies formed, how the whole cosmos came to be, they might be missing a key piece of the puzzle. We might actually have to rethink how these cosmic engines work.
So after that whirlwind tour of the latest space news, what's the big takeaway? Well, I think it's a story that's being told on 3 completely different scales.
You've got what's happening right here, close to home. The dynamic dance between our sun's power and our incredible new tech to watch over our planet. Then you look a little farther out and you get this priceless gift, a sample from another star system, reminding us we're part of a vast galactic community. And finally, you look into the deepest reaches of time, and you find out that the universe itself might not be as constant as we thought. The rules can actually change. And that's really the beauty of all this, isn't it? Every single one of these discoveries, whether it's about our own weather or the physics of ancient black holes, it just opens up a dozen more questions. It really leaves you wondering, what fundamental truth are we going to uncover next?